All right, today we're stepping into what's basically the kitchen of the future, a smart factory. We're going to uncover how AI takes this just overwhelming mess of data and turns it into pure operational gold. So let's get right into it and see how the magic happens.
I mean, just try to wrap your head around this for a second. Every single sensor, every machine, every camera, they are all constantly screaming information. It's just a wall of noise. So with literally trillions of data points flying around, how in the world does an AI know how to sift through all that chaos to find the one tiny signal that might predict a huge failure? It is a massive, massive challenge.
And that's the secret, right there. The most brilliant AI systems, they don't see noise at all. They see a pantry that's just bursting with raw ingredients. So the key, the real game changer, is to become a master data chef, to know exactly how to prep, select, and combine these ingredients to cook up something truly incredible.
Okay, so step one on our culinary journey is, of course, prepping the ingredients. Now, in the world of AI, this is called feature extraction. Before our AI can even think about cooking anything, it needs all its data chopped, measured, and perfectly ready to go. So what is a feature, anyway? Well, it's actually pretty simple. It's just one single, measurable piece of that giant data puzzle. Think of it exactly like a single ingredient. It could be the temperature of a motor, a vibration reading, or even a single pixel from a quality control photo. Each one is a potential ingredient for our AI's final recipe.
And just like in a real kitchen, these ingredients, these features, they come in all different shapes and sizes. You've got your continuous time series data, like sensor vibrations, which is kind of like keeping an eye on the temperature of a simmering sauce. Then you have discrete data, a simple on or off signal, just like a kitchen timer that's either done or not done. Image-derived features are like visually checking your vegetables for freshness. And then you get the really cool stuff, derived features, where you actually combine raw data to create something brand new and way more insightful. Exactly like a chef creating a complex and amazing spice blend.
So how do we actually prep all these ingredients? Well, there are a few key techniques. Time domain analysis, that's your basic knife work. Calculating things like the mean or variance. It's simple, but it's absolutely essential. Then you move on to frequency domain methods like FFT. This is more advanced, kind of like grinding spices to release hidden aromas and flavors, but for sound and vibration data. Then you've got wavelets, which are amazing for catching those super brief, fleeting signals, like a chef noticing a momentary aroma that tells them a dish is cooked to perfection. And finally, you have automated learning, where the AI itself starts inventing new ways to prep the data. I mean, that's like the genius chef literally inventing a whole new way to cook.
All right, so our pantry is just overflowing with these beautifully prepped ingredients. But any great chef will tell you, you don't just use everything. And that brings us to part 2. Choosing the best ingredients, or what data scientists call feature selection.
I mean, this just says it all, doesn't it? If you just shovel every single feature you've created into your AI model, it's an absolute recipe for disaster. It just creates confusion, it slows everything down, and at the end of the day, you get a terrible result. The goal here is elegance and precision, not just raw volume.
So how does our data chef choose? Well, there are two classic approaches. On one hand, you have filter methods. Think of this like a quick taste test, a fast, simple check of each ingredient's quality. It's great for weeding out the obviously bad stuff right away. On the other hand, you have wrapper methods. Now, this is the full recipe trial. You actually cook up a mini version of the final dish with a specific combination of ingredients just to see how it turns out. It's way more accurate for sure, but you can probably guess it takes a ton more time and energy.
But then we get into some really cool, sophisticated stuff. Embedded methods are fascinating. It's like the cooking process itself automatically taxes or just lowers the influence of the less important ingredients. The selection process is literally baked right into the recipe. And tree-based methods? That's like asking your team of sous chefs for their opinion. After the meal is cooked, the model itself tells you exactly which ingredients were the most critical for making its decisions.
Okay, we've prepped our ingredients, we've selected the absolute best ones. But sometimes, even with the best ingredients, you can just have too much. This brings us to our final kitchen phase, creating the perfect portion. In the data world, we call this dimensionality reduction.
See, here's the thing. You might have 10 different temperature sensors on one machine, and they're all telling you a slightly different version of basically the same story. They're all good ingredients, right? But you don't need all 10 of them. And the goal here isn't to just throw 9 of them away, but to concentrate their collective essence into something way more powerful.
And the absolute master technique for this is called principal component analysis, or PCA. So it starts with all those related features like our 10 temperature readings. Then PCA cleverly looks at all of them and finds the main underlying patterns. And then it combines all of that rich information into just a few brand new, super potent features. It is the perfect data equivalent of a chef simmering a giant pot of stock for hours and hours, boiling away all the water to create this rich, intense, and incredibly flavorful glaze. You get rid of all the extra volume, but you keep all the power.
So, we've prepped, we've selected, and we've concentrated our ingredients. We've done all the hard work. Now, it's time for the payoff. Why do we go through all this trouble? Let's take a look at the final dish and really understand why this all matters so much.
And the result? Honestly, it's night and day. If you just feed an AI raw, unprepared data, its accuracy is, well, it's okay at best. But when you serve it that carefully crafted, feature-engineered gourmet meal, the performance just skyrockets. And this isn't some tiny little improvement we're talking about. It is a total game changer.
So what does this gourmet meal actually get you on the factory floor? It means you can predict machine failures with almost surgical precision. It means way fewer false alarms that send your maintenance teams on a wild goose chase. It means the AI actually learns faster, the models get smaller, small enough to run on tiny devices right on the factory floor, and the whole system just becomes more stable and reliable.
Let me just put a number on this for you so it really sinks in. Getting this whole process right can lead to a reduction in false alarms by up to 85%. Just think about the time, the money, and the headaches that saves. That right there is the incredible power of being a great data chef.
You know, this all leads to a really interesting question. As we move into a world that's increasingly run by AI, from our factories to our cars to our finances, the real bottleneck to progress might not be the AI algorithm itself. It might just be the skill of the human data chef who knows how to prepare that perfect meal for the AI to consume. Makes you think, doesn't it?